Assalamualaikum warahmatullahi wabarakatuh. My name is Intan Iman binti Ahmad Imran, and we are Group 3, and we will be presenting about pre-stressed concrete and its two types, pre-tension and post-tension. So a little introduction for you guys, or a little fun fact: if you didn't know, concrete is actually 10 times stronger when it's in compression rather than when it's in tension. Next, there are three types of concrete that we all know of. First is PCC, which is plain cement concrete. Second is RC, which is reinforced concrete. And the third type is the type that we're going to be talking about today, which is pre-stressed concrete. So why do we have pre-stressed concrete when we have PCC and RC? So number one, PCC is very impractical because it does not have any elements that help to cater with any cracking, or it doesn't help with anything to do with strengthening. And number two, RC has some limitations, even though it has the reinforced concrete bar. So RC usually when you want to increase the span, because they can only range up from 5 to 7 meters, you would have to increase the depth as well, and this is impractical when we're talking about the weight. So let's talk a little bit more in depth on the concept of concrete. So as you can see from the figure to my left, basically a normal concrete bar, when you apply load on top of it like this, basically what happens is there's going to be compression forces on the top and tensile forces on the bottom. So what happens at the tensile forces is, as you can see, elongation. So when elongation happens, this is why cracking happens. However, now you can see with a pre-tension concrete bar, because we apply tension before it, the sort of concrete bar can be thinner, but at the same time way less. Additionally, you use less concrete and you don't get any cracking or breaking happening. Okay, so before I pass it on to my group mates, I would just like to talk a little bit about how pre-stressed concrete works. How do they mechanize and all that. So basically, how you want to make pre-stressed concrete is you take the wire and you stretch it. And then after you stretch it, this is basically putting in the tension. After you put in the tension, you release it, and then it will transfer the force to the concrete, which basically puts it into compression. This is a very basic way of explaining how it works. Pass the mic to my group mates to further explain about post-tension and pre-tension in greater depth.
Assalamualaikum warahmatullahi wabarakatuh. Now, I would like to talk about pre-tension concrete, a type of reinforced concrete that has been gaining popularity in the construction industry. To begin with, pre-tension concrete is a technique or mechanism where high-strength steel strands called tendon are tensioned before the concrete is poured. So the difference between post-tension and pre-tension is in pre, we tension first, then cast, while in the post-tension we cast first, then we tension it. So these tendons are typically made of high-strength steel wires or strands and are tensioned to a predetermined level using hydraulic jacks before the concrete is cast. Once the tendons are under desired tension, the concrete is poured around them, for example into the mold or any mold prepared by the factories. So after the concrete is poured and allowed to harden, these tendons are released and the pre-tension force is transferred to the concrete. This creates a strong and durable structure that can withstand high stresses and load with longer spans. One of the significant advantages from this pre-tension technique is that it allows for longer span without need for additional supports. This makes it an ideal choice for bridges, parking garages and other large structures. So another benefit of pre-tension is it reduces the risk of cracking, which can be a common problem in traditional reinforced concrete. Because the steel tendons are already under tension, and the concrete is less likely to crack under load or stresses. And usually this pre-tension technique is applied in precast factory, where they have all the equipment, including the abutment, the anchorage, and the pre machine that provides tension to the steel. So like in the picture, as you can see, this is one in the precast factory, where they have the abutment hold the end of the tendons to apply the tension before they casted the members. So in next slide, I will provide more details in the for pre-tension concrete production. In pre-tension concrete production, there are 7 stages overall, where the first stage is design and planning, where the requirement for the structure is needed, including the span length, load capacity, and other consideration, which will produce later the detailed drawings and specification that includes the placement of the tendons, the size and shape, and as well as the amount of concrete needed for the members. And the second stage, fabrication and placement of pre-tension tendons, where the tendons made of high-strength steel wires or strands are placed in the formwork according to the design spec in the detailed drawing. So for the third stage is anchoring the tendons, where the tendons are held in place using some kind of temporary anchors or clamps, and at the end are left protruding from the concrete to allow for later tensioning. So for the fourth stage, tensioning the tendons, where tendons are tensioned using hydraulic jacks at predetermined level, usually at 70 to 80% of the steel strength. Once the tendons have been tensioned, they are anchored in place using permanent anchors at the other side of the members. For the fifth stage is pouring the concrete, where once the tendons are tensioned, concrete is cast around the precast unit and tension tendons, where the concrete will fill the voids between the tendons and the precast units, so there will be a bonded connection between the tendon and the concrete. So for the sixth stage is curing the concrete, where the concrete is allowed to cure fully, and the seventh stage is cutting of tendons. As once the concrete has gained sufficient strength to resist the applied force, the tendons are cut. This release of tension from the tendons will result in a compressive force in the concrete that improve its strength and stiffness in longer span. As you can see in the picture, where the first picture shown the application of tension to tendons before the concreting, and you can see the end abutment and the hydraulic jack at the right. For the second picture is where they have casted the concrete after the tendon have been applied with tension, and the third picture is where they cut the tendons in both ends, and it shows the transferring process, the transferring of the tension from the tendon to the concrete. Next is the devices used in prestressed technique. The first one is the prestressing bed. The second one is an abutment, which is the one of the anchoring device to hold the one end of the tendons. The third one is shuttering or mold, where the mold of concrete should be placed. Concrete should be placed into the mold. And the fourth one is a hydraulic jack, where the tension is applied by using this hydraulic jack with required tension. And the last one is the another end of the tendon, which is the anchoring device to hold the tension in the concrete members. Due to use of these heavy devices, pre-tension technique comes with limitation. The first one is the control environment, where they have to be produced in a control environment such as factory, and most of them been produced in precast factory. The second one is the size, where the size of this section is limited due to transportation restriction and the availability of crane to lift up the members in the site. And the second one is the third one is the members, where in case of pre-tensioning, similar pre-stressed members are prepared in factory, such as in like catalog. If the size variation happens, then we have to manufacture a different mold, so it reduces the flexibility of the design. And the last one is the suitability. So for pre-tensioning, it is suitable for small structure elements which are easy to transport to the ongoing site.
Assalamualaikum. So I will continue the presentation with the introduction of what is post-tensioning. So post-tensioning is a method of reinforcing concrete that involve inserting high-strength steel cables or tendons into the concrete before it sets. So once the concrete is set, the tendons are tensioned with hydraulic jacks, which creates compressive force that help to strengthen the concrete. So this method is commonly used in construction to provide increased strength and durability to the concrete structure, making them more resistant to cracking and other types of damage. So, how does post tensioning work? So, to understand this, let's think about how tension is created when a rubber band is stretched. So, this concept is similar to how steel cables are tensioned in post tension concrete. Strong steel cables, known as steel strands, are placed inside the concrete slab in a specific pattern before the concrete is poured. So once the concrete is set, the steel strands are tensioned with hydraulic jacks, which apply force to the steel cables and create tension. So this reinforces the concrete slab and adds extra strength and durability to the structure. So before the concrete is poured, a mold or formwork is used to create the shape of the concrete slab. So the steel strands are placed inside the molds in a specific pattern before the concrete is poured. So once the concrete is set, the steel strands are tensioned with hydraulic jacks, which give the concrete extra strength and durability. So this process helps to create a strong and durable structure that can withstand a wide range of stress and strains. So to tension the steel cables in post-tension concrete, hydraulic jacks are used. These jacks apply force to the steel cable, which creates tension and reinforces the concrete slab. So the jack applies a large amount of force to the steel cables, which can be up to several hundred tons. This process helps to create a strong and durable structure that can withstand a wide range of stresses and strains. Uh, the next slide. In this section, we will take a closer look at the components in the post-tensioning system and their functionality. So the first component in the post-tensioning system is the dead end anchor. This is a device that anchor one end of the steel cable to the concrete structure. The dead end anchor is designed to transfer the tension in the cable to the concrete, creating a strong and durable connection. The post-tensioning duct is a tube that is used to protect the steel cable from corrosion and damage. So the duct is made of high density polyethylene and is installed in the concrete before it sets. So the duct also helps to guide the steel cable during installation and tensioning. The live end, also known as the free end, is the opposite end of the steel cables from the dead end anchor. So the live end is not anchored to the concrete and is free to move during tensioning. So this allows the cable to be tensioned and to a precise level and ensures that the tension is evenly distributed throughout the structure. So the stress pocket is a device that is used to transfer the tension in the steel cable to concrete structure. The stress pocket is installed in the concrete and is designed to prevent the steel cable from pulling out of the concrete. So the cable wedge is a component that is used to secure the steel cable inside the stress pocket. So the wedge is made of high strength steel and is designed to grip and cable tightly, creating a strong and durable connection. The next slide is post-tensioning is an effective method for reinforcing concrete structure. There are two types of post-tensioning system, which is bonded and unbonded. Let's take a look at how they differ from each other. So a bonded post-tensioning system is also known as a grouted system. In this system, the steel tendons are covered with a protective coating to prevent them from being damaged by the surrounding concrete. After the tendons are tensioned, they are coated with grout, which fills the gaps between the tendons and the duct. So this helps to bond the tendons to the concrete, which improve the transfer of forces between the tendons and the concrete. So the grout also provide additional protection against corrosion and helps to increase the durability of the structure. The and unbonded post-tensioning system, on the other hand, is not covered with a protective coating, and tendons are not bonded to the concrete. Instead, the tendons are coated with a layer of grease or oil to prevent them from being in contact with the concrete. So this system is commonly used in situations where corrosion protection is not required or where the tendons may need to be replaced in the future. However, the downside of this system is that the transfer of forces between the tendons and the concrete is not as efficient as in bonded system. So for the next sections, let's take a look at the pros and cons of each system. So first one is bonded post-tensioning system. One of the major advantages of bonded system is that they provide a higher level of bond strength. This makes them ideal for use in high stress application, and they can even be used to strengthen the existing structure. So a bonded system also allow for more precise control over pre-stressing force, and they tend to be more durable and resistant to corrosion. However, there are also some downside to bonded system. They require more time and effort to install and may be more expensive than their unbonded counterparts. Additionally, the grouting process that is necessary with bonded system can create quality control issues. Now let's take a look at the pros and cons of unbonded post-tensioning system. One of the biggest advantages of unbonded system is that they are faster and easier to install. They requires less material and labors and provide greater flexibility in tendon or cable placement. Plus, they eliminate the need for grouting. However, unbonded systems also have their drawbacks. They provide a lower level of bond strength, which may not be suitable for high stress applications. They may also be more prone to corrosion and do not provide the same level of durability and resistance to corrosions as bonded system. So the next slide is the advantage of post-tensioning concrete. Post-tensioning concrete offers several advantages over traditional concrete structure. It provides increased strength, reduced cracking and deflection, and allows for more efficient use of materials, resulting in cost-effective design. Post-tensioning also improves durability and provides greater design flexibility, making it a popular choice for a wide range of construction projects. Next is the application of post-tension concrete. It is used in a variety of applications, include the high-rise buildings, bridges, parking structures, and stadiums. By reinforcing concrete with high-strength steel cables, post-tensioning can provide increased strength and durability to these structures. This allows for the construction of taller and more complex structure that can withstand a wide range of stresses and strains. Post-tensioning has become an essential technique for modern construction, enabling engineers to create safer and more efficient structures that can stand the test of time. Thank you.
I'm not gonna bore you with any more, but from here you can see the major differences between pre-tension and post-tension concrete. So what we just want to try to show you guys or make you guys understand is that both pre-tension and post-tension concretes have their own advantages of making sure that we can build buildings that are much more longer lasting, while at the same time reduce any cracks or breaking. That's it from group 3. Thank you so much for watching, and bye. Assalamualaikum.